All right, hey gang, just want to go over solving multi-step equations with you guys. I'm hoping that when we go over solving one-step equation, you guys remember that multi-step is just another layer. It's adding another dimension, and the focus still is going to be how do you get your variable by itself, okay? So in taking a look at the very first one right here, let me get off the webcam. There you go. What we need to do, we want to isolate this negative a, okay? Well, how do I do that? I have to do the opposite of what we currently have with negative 5. So I'm going to go ahead and say the opposite of negative 5 is to add 5, or the opposite of minus 5 is to add 5. In doing that, now I want you to notice, I'm going to try to keep everything organized. You want to do the same thing when you work through algebra problems. So if I cross that off, this guy comes straight down. So we have negative a is equal to negative 4, or I'm sorry, positive 4, okay? Now from there, this is actually a negative 1a. If you want to put that negative 1 in there, you can. But this is negative 1 times a. How do we undo multiplication? We're going to divide by negative 1. Divide by negative 1. So in the end, we're left with just a is equal to negative 4, okay? Now how do I check this? If I plug this back in, right up here, okay, we have negative a minus 5. Now, two negatives make a positive, so 4 minus 5, that equals negative 1, which is what we started with. So in the end, our a value of negative 4 is correct, okay? All right, moving on to the next one. Let's see here. I'll just do this one right here. Now we want to get 3x by itself. We want to isolate that 3x. So I'm actually going to cover that up and ask myself on the left-hand side of the equation, how do I get this negative 2 over to the other side? Well, the opposite of negative 2 is positive 2, or the opposite of minus 2 is plus 2. So in the end, I'm going to take 3x, set that equal to 6. How do I get x by itself from here? I'm going to divide by 3. So x is going to equal 2, okay? Now, again, I want to check that, so I'm going to plug that 2 in right here. So we have 6 minus 2, which is 4, and that's what we needed to get. So if I look here, x is equal to 2, okay? So I'd like you to go ahead and finish up these two for me, as well as 1a and 1b down here, okay? Multi-step equations. See if you can do that. Now I know this with story problems, sometimes we freak out. Don't freak out here. Let's read through this and see if we can put it together into an equation. So Len read 3/4 of a novel over the weekend. Monday he read 22 more pages. If he has read 220 pages, how many pages does the book have? Well, what we're looking for is how many pages the book has. So I'm going to say x, the unknown part, is the number of pages of the book. Okay? So from here, let's see here. 3/4 of the novel. Well, the number of pages is x, so I'm going to say 3/4 of x. Now, when you think of, remember, that means to multiply. Okay? So if I take 3/4 of the book and I go ahead and read 22 more pages, I then know I've read 220 pages. Okay? So hopefully that makes sense how I kind of scripted that equation together. Then you want to go ahead and finish the problem out for me there. Okay? All right, going to the back side. Okay. Yeah, that looks good. We want to convert some of these expressions into, or these sentences into expressions. So here's what it says. LB has won 10 consecutive BBC track championships. Okay, consecutive means back to back to back and so on and so forth. Okay. Give an example of 3 consecutive integers. Well, an example would be like 4, 5, 6, or 9, 10, 11, or even -2, -1, and 0, okay? Consecutive, right in a row. The next one says, give an example of 4 consecutive odd integers. Well, we can go with 3, 5, and 7. Or, 4. Let's go 9. We could even say 21, 23, 25, 27. Okay, consecutive. Now, what some students struggle with when they think of odd integers, they don't understand that this is still a jump of 2, a jump of 2, a jump of 2. So be careful with that part. We're increasing by an even number to get to the next odd number. So the last part here says, if n is the first integer, describe how to show the sum of 3 consecutive integers is 15. Well, I'm going to show this here. N is the first integer. Okay? And if they're consecutive, they're right in a row. So they're increasing by 1. Okay? Increasing by 1, consecutive integers. So n plus 1 is going to be the second integer. And n plus 2 is the third integer. Okay? If you're having trouble visualizing this, let's say that this is 8. If I add 1, that's 9. If I add 2 to 8, that's 10. 8, 9, 10. 3 consecutive integers. Now, it says the sum, don't forget that is to add, so I'm going to add these guys together. Okay, and the word is, remember, it means equals. So if I was to put something down, equals, okay? So I'm adding these together. If I add all the variables together and the other two like terms, we get this. If I subtract 3 from both sides, I get this. And then if I divide through by 3, you get this, okay? Now, we're not done when we get to this point because that's the first integer. The second one is 1 more away from that, so 5, and the third one is 2 away, 6. So 4, 5, 6 is actually our answer. Now, remember, the sum is 15. 6 plus 4 is 10, plus 5 is 15. So I hope that made sense to you as far as solving multiple step equations. I want you to finish up the ones that we didn't already get a chance to do, and then bring any questions you have to class. All right? Anyways, have a great night, folks. We'll talk to you later.